Good day everyone, I'm Cyberly Ragos. So now we are going to discuss tests in identifying convergent and divergent series. So the test that I've chose is the ratio test and the limit comparison test. So now we are going to discuss first the ratio test. So ratio test. So we have the three basic idea here in our ratio test. So what are those basic ideas? So first, let's say if we take the limit of n goes to infinity of the absolute value of a sub n plus 1 divided by a sub n. Let's say we get the sum of limit L and that's limit is less than 1. So, and the series is going to be absolutely convergent. The series is going to be absolutely convergent. So second, let's say if we take the limit of n goes to infinity. Of the absolute value a sub n plus 1 divided by a sub n is equals to, let's say if we get the limit of L is greater than 1 or the limit goes to infinity. Then the series is going to be divergent. So next, let's say if we take the limit of n goes to infinity, of the absolute value a sub n plus 1 divided by a sub n is equals to 1. So, if it is equals to 1, then the series is going to be inconclusive. So, it have no conclusion or it means that it needs further test. So, the series is going to be inconclusive. So these are the three basic idea of our ratio test. So if the series is going to be absolutely convergent, then the limit is less than 1. So if the series is going to be divergent, then the limit is greater than 1 or if it is goes to infinity. And last, if our series is going to be inconclusive, then it must be 1 is equals to 1. So let's have some example. So first, consider the series of 3 to the n divided by n factorial. So we are going to determine if the series is going to be convergent, divergent, and inconclusive. So now, first, we are going to find first the a sub n plus 1 and a sub n. So let's find the a sub n plus 1. So it is our a sub n plus 1. So the n here will become n plus 1. So next, let's find our a sub n. So our a sub n, it is the original. Then next, let's find the limit of n goes to infinity. So it is our limit n goes to infinity. So it is our a sub n plus 1. We have the 3 to the n plus 1 over n plus 1 factorial, and it is our a sub n divided by
3 raised to n
over n factorial. So now we are going to solve it. So limit n goes to infinity. So 3 to the n plus 1 and n factorial. So 3 to the n plus 1 n factorial divided by n plus 1 factorial and 3 to the n. N plus 1 factorial times 3 to the n. So now, we are going to simplify it. Then, 3 to the n plus 1 will be going to limit n goes to infinity. So, our 3 to the n plus 1 here will become 3 to the n times 3 times our n factorial. So, n factorial. So, divided by, so our n plus 1 factorial here will write as n plus 1 minus 1 factorial times our 3n. So now, we're going to cancel 3 to the n because it is the same here. 3 to the n and n factorial also. And n plus 1 minus 1 factorial is same also as n factorial. So we are going to cancel also the n plus 1 minus 1 factorial. So now, we are going to find its limit. So limit n goes to infinity. So our 3 divided by, so our n plus 1. So we all know that n has the biggest exponent. So we are going to divide this on n. So 3 over n divided by our n over n plus 1 over n. So now, we are going to solve it. So 3 over n will become 0. N over n will become 1 plus 1 over n will become 0. So 0 over 1. So 0 divided by 1 is equals to 0. So 0 is less than 1. Now, let's see the basic idea of the ratio test. So, if L is less than 1, then it is absolute convergence. So now, we can say that 0 less than 1 is convergent. So, our series, we can say that it is absolutely convergence because 0 is less than 1. So now, let's proceed on our next example. So let's proceed on our next example. So consider the series of 9 to the n plus 2 times n to the 2. So, divided by 4 to the n. So, now, let's find our a sub n plus 1 and a sub n. So, our a sub n plus 1 is equals to 9 to the n plus 1 plus 2 times n plus 1 squared over 4 to the n plus 1. So here in our a sub n plus 1, we all know that our n must n plus 1. So a sub n is equals to 9 to the n plus 2 times n squared divided by 4 to the n. So our a sub n here will be the original. So now, let's take the limit n of n goes to infinity. So limit of n goes to infinity. So our a sub n plus 1, 9 to the n plus 1 plus 2 times n plus 1 squared over 4 to the n plus 1. And our a sub n, so divided by 9 to the n plus 2 times n squared over 4n. So it is our a sub n plus 1 and it is our a sub n. So now, we are going to simplify this. So the limit of n goes to infinity. So, we are going to solve it. So 9 to the n plus 1 times n plus 1 squared and 4 to the n. So 9 to the n plus 1 plus 2 times n plus 1 squared times 4 to the n. Divided by, so 4 to the n plus 1 and 9 to the n plus 2 times n squared. So 9 to the n plus 2 times n squared times our 4 to the n plus 1. So now we are going to simplify it. So limit of n goes to infinity. So our 9 to the n plus 1 plus 2 here will become 9 to the n times 9 raised to 1, 9 raised to 2. Times, so our quantity of n plus 1 squared here will become n squared plus 2n plus 1 times our 4n here. Divided by, so we can simplify this 9 to the n plus 2. So 9 to the n times 9 squared times n squared times, we can simplify this also. So 4 to the n times 4 raised to 1. So now we are going to cancel 9 to the n because it is the same also here. 9 to the n, so 9 squared, and 4 to the n. So limit n goes to infinity. So 9 n squared plus 2n plus 1 divided by, so n squared and 4. So it will become 4n squared. So now we are going to solve this first. Limit of n goes to infinity. So, we are going to distribute 9 times n squared will become 9n squared plus 9 times 2n will become 18n plus, so 9 times 1 will be 9 divided by 4n
squared.
So now, we will see that the limit n goes to infinity, 9n squared plus 18n plus 9 divided by 4n squared. So, we will see here that n squared has the biggest exponent. So, we are going to divide this all to n squared. So, 9 n squared divided by n squared. So, limit n goes to infinity, 9 n squared divided by n squared plus 18 n divided by n squared plus 9 divided by n squared over or divided by 4n squared divided by n squared. So let's solve. So 9n squared divided by n squared will become 9 plus 18 and divided by n squared will become 18 divided by n plus 9 divided by n squared. So we are going to copy this 9 divided by n squared divided by, so 4n squared divided by n squared will become 4 only. So let's solve. So 9, so 18 divided by n will become 0 plus 9 divided by n squared will become 0 also and 4. So, it will become 9 over 4. So, 9 over 4 is greater than 1. So, now, we can say that the original series is divergent because the divergent, if L is greater than 1 or it goes to infinity, then it is divergent. So, our example here, 9 over 4 is greater than 1 is divergent. So, 9 over 4 is greater than 1, then it is divergent. So, now, we are going to proceed on our next example. So, consider the series of negative 1 to the n divided by n squared plus 1. So, now we are going to find a sub n plus 1 and a sub n. So, we are going to find a sub n plus 1. So, negative 1 raised to n plus 1 over n plus 1 squared plus 1. So, here in our a sub n plus 1, the n here in our series will become n plus 1. So, next, a sub n. Negative 1 raised to n over n squared plus 1. However, in our a sub n, it is the original. So, now, we are going to take the limit of n goes to infinity. So, limit n goes to infinity. So, negative 1 raised to n plus 1 over n plus 1 squared plus 1 divided by negative 1 raised to n over n squared plus 1. So, it is our a sub n plus 1 and it is our original. So, our a sub n. So, now, we are going to solve it. So, limit of n goes to infinity. So, negative 1 raised to n plus 1 times n squared plus 1. Times n squared plus 1 divided by, so, n plus 1 squared plus 1 times negative 1 raised to n. So, negative 1 raised to n times n plus 1 squared plus 1. So, now, we are going to simplify it. So, limit of n goes to infinity. So, we are going to simplify this, negative 1 raised to n plus 1. So, it will become negative 1 raised to n, negative 1 raised to 1 times n squared plus 1 divided by, so, negative 1 raised to n times, so, the quantity of n plus 1 squared will become n squared plus 2n plus 1. Plus 1, we are going to copy this. So, now, we are going to solve it. So, limit of n goes to infinity. So, negative 1 raised to n is the same here. So, we are going to cancel it. So, negative n squared minus 1 divided by, so we are going to copy this. So, n squared plus 2n. So, 1 plus 1 is equals to 2. So, now, we are going to find its limit. So, we will see here that n squared has the biggest exponent. So, we are going to divide this on n squared. So, limit of n goes to infinity. So, negative n squared divided by n squared minus negative 1 divided by n squared over, so n squared divided by n squared plus 2n over n squared plus 2 divided by n squared. So now we are going to solve this. So is equals to negative n squared divided by n squared will become negative 1. Minus, we are going to copy this. 1 over n squared divided by, so n squared divided by n squared will become 1 plus 2n divided by n squared is 2 over n plus, we are going to copy this. So 2 over n squared. Then let's solve this. So negative 1 minus, so 1 over n squared will become 0. Over, so 1 plus, so 2 over n will become 0 plus 2 over n squared will become 0 also. So negative 1 over 1. So negative 1 divided by 1 is equals to 1. So let's get the absolute value of the negative 1. So the absolute value of the negative 1 is equals to 1. So 1 is equals to 1. So now, we can say that the original series is inconclusive because if it is equals to 1, then it is inconclusive. So, our example here is equals to 1 so that we can say that it is inconclusive. So, did you get it? If it is equals to 1, it is inconclusive. So, if it is less than 1, then it is absolute convergence. Then, if it is greater than 1, then it is divergent. Then, if it is equals to 1, then it is inconclusive. So, these are the 3 basic idea of our ratio test. So, it's all about the ratio test. The convergent, divergent, and inconclusive.